Welcome to another video, and I have made a massive mistake. I bought one of the most infamous Yamaha amplifiers to ever exist in the repair world. This is the Yamaha B-6, or as I commonly refer to it as the Pyramid of Doom. It has been featured in quite a few, or maybe not that many YouTube channels, and driven people to the edge of insanity with its very difficult build quality, its complexity, its very unusual design. And I honestly don't know why I bought this thing. I guess it just came up for sale at a time when I was looking for interesting video content. And I don't think it gets any more interesting than this. This thing looks like something out of Blade Runner. I think it is the epitome of 80s design. So we're going to be tearing this thing down. I don't know what we're getting ourselves into. I don't know if this thing works or not. I have not powered it up yet. We do have the original brochure that came with it. So we're going to do an inspection and a look over, and I'll take you through why I haven't powered this up yet, and we're going to dive into it. So let's get started. So before we tear this thing down, I think we better just have a look at these marketing materials and just try and wrap our heads around what is actually happening here. Now, I am a complete idiot when it comes to understanding this, but I can try to point out a few things that are interesting. It does still have output transistors per se, but I don't believe they're doing exactly what they would normally do in a traditional amplifier design. The main reason I mention that is because it has a triac on the incoming power for the mains transformer, and they're doing some interesting technology where they're chopping up the incoming sine wave, which is used to proportionally adjust the plus and minus supply rails for those output transistors. And that is a very, very different take on an amplifier design. The only other company that tried something around this was Carver with their magnetic field effect transformer technology, I think it was called. And in Yamaha's case, they're calling it X-Power. And there's a lot of debate if this was a stolen technology by Yamaha, if it was licensed from Carver, or if it is just something completely different that didn't stick and they just discontinued it. I don't really know, and there's a lot of debate around this whole thing. But the specs they claim, if it does what it says on the packet, is just really, really impressive. It has a relatively small power transformer. It has very little in the way of supply capacitors for an amplifier of this capacity. It is rated at 200 watts RMS per channel at 0.003% THD, which is absolutely ridiculous. Looking at the back here, it's claiming a frequency response out to 100 kilohertz, which is utterly insane, because I would have thought that there would be very big limitations on how fast this thing can switch its voltage rails for a given load, and also the frequency response that this thing is operating at. But 9 kilos for a 200 watt RMS amplifier is just nuts. I don't think in this era there were any amplifiers under 30 kilos, maybe 25 kilos that could achieve this sort of power output. And they're also claiming that it will do this power output at a much, much higher efficiency without generating a ton of heat or wasting a ton of power. We will be able to do a bit of testing in regards to that. I can probably use my Sansui Alpha, because that'll do 200 watts RMS. We can probably run them back to back and see how much power consumption each of them is using for the given power output. Keeping in mind that my Alpha is a 100 volt amplifier, so it is not a apples to apples comparison, but I think we can get a general idea of, you know, if this thing is actually efficient or not. It'd be really cool to see if that is actually the case. So let's start tearing this thing down, and I'll try to put in some scans of this, and people can sort of peruse through that also. Just before we flip it over, I thought we'll just have a look around the exterior of it. Now, the scratching on this looks really bad, and this is actually one in better condition, believe it or not. I have not seen many of these in good condition. They are like a 2-pack enamel or something, and it scratches really easily. People like to put things on top of them and rub them down, and they just scratch really badly. They should have done it in like a matte black or something. But here's the giant heatsink on the back of it. This is all solid metal, the entire thing. This entire outer chassis is a heatsink, basically. So yeah, let's flip it over. So looking at the bottom, a lot of red flags already. There's a screw missing here. It looks like there's a crack around the die casting. Mismatched screw here, repair stickers. Oh yeah, I'm not looking forward to this. Yeah, power cords, speaker on and off switch. That's really interesting. We've got a ground, inputs, speaker terminals. I can see the output transistors there, and the bottom is not looking great overall. So yeah, not a lot to look at, but a lot of red flags that we're in for something interesting inside this thing, that's for sure. So I've got this thing split open. There was a lot of hidden screws inside this chassis, and we've got it open finally. Main reason I wanted to open it up is I knew from some research that this thing had a lot of reefer capacitors in it. And for anyone who doesn't know, reefer capacitors are very well known for cracking. These are supposed to be safety capacitors, but they will crack and they will absorb moisture and become conductive and basically explode, catch fire, all sorts of fun things. One of them has already been replaced here, and it looks like it already did fail. There is significant scorching, melting, lots of good stuff around here, and whatever moron took this thing apart didn't even bother changing all the other reefers. There's another 3 here, and there's more on the underside somewhere, which I've got to dig up. And I'm seeing a lot of red flags with this amplifier already that could make this thing a paperweight before I even get started. These transistors looks like they've been replaced, and they're not even attached to the heatsink anymore. So yeah, I need to take this thing off the metal case and have a look at what the hell has happened here. It looks like the optocoupler has been removed at some point. I am seeing resistors and diodes that have been messed with. There's one here that's been screwed with. This is just freaking nuts. I don't know who's been in here, but it's not looking good at this point. So I'm going to get this bottom casing off and let's see what else we've got. God, this thing's heavy. Right, so I got all this out. It doesn't actually come apart too badly. It's pretty simple to strip down. This bottom plate looks really bad, and it does just sort of sit on the transformer. So you can, I guess, do a quick power up as it is like this without reassembling everything, but you wouldn't be able to do any significant testing because there's only this metal plate with all those outputs. There's no real heat sink to speak of. There's a lot of things that are really concerning me with this. It has had a lot of work done to it by the looks of it by people who are very incompetent and did not care about the work they were doing. These look like all original outputs. These most definitely are not original. They are from a very different year. Maybe 95, I don't know, but they are not the same as the other channel. I can also tell that these two are different from these two. So it appears that this channel probably had a catastrophic failure at some point and blew out everything. And this side is mostly original. But these are not original on both sides. They are supposed to be similar to these, probably not the same type, but same type of package, and mounted to this sort of metal plate, which is like a heatsink and then goes through the chassis, but probably more for thermal coupling. But they are not even attached to anything. They are literally just sitting there floating in midair with no cooling whatsoever or insulation. So if they decided to touch something, that would have been really bad as well. I don't know if these work or not. I don't know if any of this works. So we're going to go one step at a time. The main fuse is intact, which I guess is a good sign, but it also looks very new, which is not a good sign. So we have to address this first. This is a big problem, and the leads are not going to reach and mount the way it is. So I have to be inventive with what I have to work with here. So what I've decided is I'm going to turn these 90 degrees, mount them using these inside screws, trim the legs, and run wires to the PCB and get rid of the other screw and use nice silicon insulating pads, get rid of all the thermal paste and everything. And that is going to be my sort of cheap testing scenario at the moment to see if this thing actually works. We have some new capacitors to put on the big power board under here where all those reefer capacitors are. They're not A few of them are a slightly different value. This is just a test, and then I will order, you know, the usual high-end parts if this thing shows any sign of life or hope that we are going to get this thing working. There are more reefers here for snubbing the main power switch also, which we need to sort out. There is a transistor in here which has been very, very hot. It has that white sort of chalky overheated appearance to it, so we need to deal with that. There are resistors here that they look like they're fused resistors that have been lifted out of the PCB, and another resistor has been added in series. Why, I don't know, which is a big problem because I don't know if I should reverse it, if it was a service bulletin or whatever. There is no documentation around why this was done. If it was to accommodate these different transistors, that is a possibility also, but I'm not sure what is going on here. It also looks like these diodes have been messed with. There's a lot going on here, and I'm sort of just praying at this point, and we're going to start to patch this thing up, see if we get some life out of it, and then we'll go from there, because I don't even know if I want to invest a lot of time and money into this if it is just a complete wasteland of blown up parts and things like that. It is a very cool amplifier, but we need to have something to work with that is not a complete basket case. So let's get this on the other bench. We're going to start by removing these, sort of clean it all up, rebuild it, try to beautify it, make it practical. I'll do one off camera, and then I'll do the other side on camera once I know what I'm doing. And then we'll go to the capacitors, I think, get all that swapped out, and then maybe we'll try firing this thing up and see what happens. For everyone who's probably going to say, why don't you use a dim bulb tester or a variac to safely turn this thing on? It doesn't work, apparently. You have to turn this thing on, raw dogging it, because the way that the triac and everything operates, it's similar to a VFET sort of situation where you're probably going to do more damage running it on a current limiting source as opposed to just turning it on. So anyway, let's get started and see what happens. Right, so we're all set up with the Leaning Tower of Monstrosity, whatever the hell this thing is at this point. It's just got it sitting on a block of wood. All the options are just hanging out on top. It's about all I can do. I'm not going to put this together until I see a lot of life from it, and I don't really want to put it together, period, until it's rebuilt, to be honest. So I'm going to have a ponder about where we're going to go with this, depending on what happens. There's a thick metal plate on the outputs. It should be okay for a short period of time. I'm not too worried about it getting too hot. We'll worry about that later. It's a power LED and a protection LED. So the protection LED will either stay off or it will turn off pretty quickly, usually. There's a protection relay here, which should engage if the amplifier is happy with everything that's going on, and that should activate it. So if it comes out of protection, we're probably looking good. And I'm going to use my power meter just to keep an eye on it, make sure it's not running away and has a dead short or something. So it'll probably have like a decent power spike, and then it should just settle down pretty quickly. So we'll see what happens. It's either that or it's going to nuke itself pretty much instantly, and there's not much I'm going to be able to do about it, to be honest. So let's see what happens. Cross your fingers and toes. And yeah. Whoop. Okay. Hey, look at that. All right, we're out of protection. Power consumption is very low, actually. That's very, very low. But from what I remember from the service manual, the bias is very low for this amplifier anyway, so that's not really surprising. No real heat. I am feeling some stray current in this metal plate though, but these are insulated plates, so there shouldn't really be anything happening on those. But I think this one, there's definitely something going on there because I can feel something through it. Yeah, okay, so we're looking good. Everything was looking happy. So I'm not going to run this, you know, as is. Like, there's not enough metal here to sink a decent amount of heat into. So I'm going to try and rig up something to dump more heat into, and then we're going to just run it as it is still, and we're going to try and put a sine wave into it and see what we get out of it. I think that's going to be the best course of action before we go any further with this project. So let me see what I can rig up. So this is about the best I can come up with. I've got a giant aluminium block, which I'm just going to dump all the heat from the outputs into. I've got my oscilloscope probes connected up to the speaker outputs. I've got some dummy loads here, which I've just clamped to the same heatsink. May as well just reuse everything I've got. So I've already got everything hooked up with my DAC, feeding a 1 kilohertz sine wave. And I'm going to run this up to 10 watts. That's as far as I'm going to go with it at the moment. So that's about 10 watts there. Channel balance is pretty good. Not too bad there. I am a little concerned the gain is quite high for 10 watts, I would have thought. So I need to double check that, what the actual gain is on this thing. We're looking at about 140 watts for 10 watts per channel, which is interesting. It is jumping around a little bit though, which is not something I normally see. I wonder if that has something to do with the triac and the power factor. Yeah, but it's working. It is, this heatsink is warming up now, so we're definitely getting some heat, but it works. So, you know, we can back this down to about 1 watt per channel, which is about 2.8 volts. And the channels are drifting a little bit now. They were pretty much perfect before, but that's probably nothing to worry about. There's probably barely anything in that. So, yeah, look, it works more or less. Obviously, it's not ideal how it's set up at the moment, and I'm really not sure what to do with this amplifier. Do I just sort of change what's needed and put it back together and put it on a shelf? Do I do a full restoration on it? I'm not really sure. I don't generally only restore amplifiers that are good candidates and have good bones. And I don't like that this thing's been messed with stripped screws everywhere, and there's a lot of things that need to be fixed up. I already had a wire break on the line input for the power amp, and I had to fix that quickly so I could run both channels. There's just a lot of crap that I'm going to have to deal with in this amplifier. So everyone, let me know what you think. Do you want to see this thing rebuilt from the ground up? And we'll see what there is to work with. Do you think it warrants being completely resurrected to brand new? I'm not even sure how far we can go with this. You know, I'm happy to leave a lot of things. Oh, these don't actually get that hot either. That's interesting. They get warm. I would like to redo all the thermal paste and everything, but I'm just not sure if I should completely strip it and rebuild it again. It's a lot of work. So let me know what you think, but it is a working candidate at this point, and you know, we have a success, I guess, for the time being. So yeah, thanks for watching another video, and we will be back with another one soon.